About Talend, right? Talend is an open source ETL tool, right? And the advantage it has is it's a code generator. So whatever the code we are developing in Talend will be converted into a Java code in the background, and you are installing only the Java code into your ETL box or something, right? And it runs as a Java code. So you don't need an installation such that in case of the free version. So you can just create a job here and export it into a Java code and put it into the server. From there it can run as an independent job without any installation or anything. All the related packages will become along with that package itself. So that's how Talend works. So we'll move forward. Like how ETL tools connect to Hadoop is like, so the ETL tool should reside in somewhere, right? So say for example, you have a node in the whole cluster, or a separate node which has connectivity to the name node, the job tracker, and the hive installed locally in that machine, pig installed in that machine in the client. Assume that everything is there in that ETL box. You can call it as an extractor box where it works. It just acts as a separate ETL node connected to which has connectivity to the existing Hadoop cluster. So you can run your ETL jobs in that particular node, and run your Hadoop jobs. For streaming jobs, if you're writing a streaming jobs in the ETL tool, you can submit as a normal mapreduce jobs calling in the command line itself. So there is not much change in the streaming side. But we will concentrate mostly on Hive and Pig in today's session. Hive is using the thrift server to connect to the actual the cluster. And Pig will automatically, in case if you are developing a Pig script in the ETL in Talend, it will submit as a mapreduce job to the job tracker itself, and then later it keeps track of that mapreduce job. So first we will go through like how we can start a thrift server and what is a thrift server. So thrift server is nothing but we'll start with the Hive, right, and then we'll go over Pig later. Say for example you can. So this is my console. So what I'm running now is I just installed. Can you see my window? We start a thrift service. Thrift service is nothing but just like a command line entry for Hive. So you guys have worked with the command line interface of Hive or Hue, right? So if you enter a Hive command, it just opens a command line window where you can run your code, right? So what thrift service does is it just opens up a port in that box, in that box for any other and listens to that port for any other query submission. So in this case, we have opened in the current console itself where we open the box for further querying, right? Instead, what we are going to do is start it as a server. This is a command. So Hive service, Hive server. This service starts listening for any Hive queries in this command, in a particular port. The default port is 10,000. So what it does is when I give this service and starts this Hive server is a service which is a program which actually starts this thrift server. So you have to connect to a Hive through this designated port and machine. Say for example, in a cluster, you have a cluster and you have an extractor ETL node where you have Hive installed, and that node should have connectivity, as discussed already, should have connectivity to all the cluster nodes. When you start this thrift server in the extractor node, right, it channels all the Hive queries to this extractor node and runs inside the cluster. So it's just like a listener for the Hive CLI, or you can It just a listener for the hive to CLI. Okay. So I'm starting this thrift server. So it mentions, okay, thrift server start. If you check this, we can run a command lsof. So it just scans through all the port, whether you can check if it is listening. So the 10,000 port is listening now. The default is 10,000. You can also start a thrift server in a designated port. If you want different port for different projects, you can start as many thrift processes as possible in the extractor node, so that no project will clash actually. So we started the thrift server. And whenever you submit the job, you need to configure your job into this thrift server. Okay, and internally it manages this. In the highway itself manages submitting the mapreduce and all the stuff internally. So this is a very key concept here. And I want to mention, like, I'm running a DerbyDB metastore. It's not a MySQL or database-based metastore. What's the problem with the DerbyDB is you cannot have concurrent connections for to the same hive metastore. What that means is you cannot have multiple connection, a CLI open, and also a thrift connection to the same metastore. So that's not possible. That's a problem with using the default DerbyDB for your metastore.